So let us understand the concept of first. We have few things to understand here. We have to understand the concept of mathematical modeling applies to mechanics. Okay, what is a mathematical model? Mathematical model is something like we take a real life problem. Okay, something which is happening around us. We take that in terms. We take the problem, try to model them in a mathematical equation, whether it is a differential equation or a system of equations. So we write that in a form of an equation. After we write that form of an equation, we try to solve the equation. Whatever the solution is there, we try to compare to the real life problem.
Okay.
Okay, if the solution is matching to the real life, then very nice. That means our model is giving a good answer. If that is not happening, then go back to the model, change the model, and then do the calculations again. That is how we do. So what are they telling is the concept of mathematical modeling to our mechanics. That means we are modeling some real life problems in mechanics and then try to understand how it happens. Okay, how does the solution match with the real life? So next concept is apply some common assumption of some theory of mechanics. So some mechanics theory is there. Height, with respect to height, with respect to distance, with respect to projection, etc. We use the concept of mechanics to understand the problem. And then of course SI units are very important. Bringing everything to a single unit in mechanics is very important. And then we know the difference between the scalar and the vector quantity. You know the difference between scalar and the vector quantity?
No.
What is a scalar? Scalar is a quantity like you don't have a direction. Okay. Probably in physics you would have learned in detail. Scalar quantities are the quantities which does not have direction. Vector quantities is the quantities which has direction and magnitude. So magnitude in the sense you have some value. Okay. Like scalar quantity, how can I tell? Like if I tell vaguely a distance, okay, just cover 5 kilometers. You can go in any direction and cover the 5 kilometers. Correct? No, north, south,
Yeah.
east, west, anything. But if I specifically tell cover 5 kilometers in northeast direction, so I am specifying the direction also. Something which is giving you direction and which has some value, then it is called as vector.
Okay.
Okay, when I'm talking only about a quantity or anything which I specify with respect to numbers, then it is called as a scalar. Okay.
Okay.
So here, as I already told you, this I already explained right now. Mechanics is a motion or a action of an object, forces of an object. What is mathematical modeling? They have given in terms of figure. You take a real life problem, you do some assumptions and solve the problem, and then repeat. If it is suiting to the solution, see they've given yes or no. Can you see the last line?
Yeah.
Yes or no? S means your solution is correct, then very good. Okay, there's no problem. If it is not correct, go back to the model, do the corrections, and then play with the model again. Get something very. We are not telling get exact solution to the real life problem. At least very accurate to the real life problem. Very near to that near life problem. So let us see the problems. You will understand better. Okay.
Okay.
See this example, a motion of a basketball as it leaves a player's hand and passes through the net can be modeled using the equation. They have already given you the equation. I told you, no, some real life problem. What is a real life problem here? A person is playing a basketball and he leaves the ball leaves the player's hand and passes through the net. Okay, it passes through the net, and that passing through the net, the equation they have given you. Okay, the equation is h is equal to 2 plus 1.1x minus 0.1 x square. They have given the equation. The real life problem you understood, no?
Yeah.
The real life problem is that the ball is passed from the player hand and it passes through the net, and the equation is also they have given. You don't have to worry about the equation. What does the h stand for here? H is the height of the basketball above the ground, and x is the horizontal distance traveled. Okay, both are given now. Find the height of the basketball. Okay, find the height of the basketball. You have to find the value of h. that is the height of the basketball. What are the two conditions? When it is released from the hand, when it is released, what is the height of the basketball? At the horizontal distance 0.5 meters. And also second question says this, use the model, use the same model to predict the height of the basketball when the horizontal distance is 15 meters from the player. Comment on the validity of this prediction. So let us take one by one. A very simple actually, because the model is already there. You don't have to do anything over here. What you have to do is you have to just substitute the values.
Yeah.
Okay, take the value of, take the H equation, okay? H is equal to 2 plus 1.1x minus 0.1 x square. Take that. So what you have to do, when you remember that when the when an object is at rest, okay, when it is not at released from your hand, there is no motion of the ball, right? There is no motion of the object. You're starting from your home to your school, okay? You have still not started, you have to start. So you see that the motion is zero right now, right? The same thing happens with the ball. Still you're not released from your hand, correct? When it is released, they are telling, correct? When the ball is released at the start of the motion, x is equal to 0, isn't it?
Yeah.
The x is 0. So at that condition, the height will be 2 meters, right?
Yeah.
Now they're substituting x. The second condition is the horizontal distance is 0.5 meters. Now substitute x is equal to 0.5 and see what is the height. Just a simple calculation. Okay, are calculators allowed in the exam?
Yeah.
Okay, nice. So 2.257 you get. So next they're telling you see the model. Take the model as horizontal distance as 5 meters. 15 meters. So substitute the value of x is equal to 15 and say the height is 4 meters, minus 4 meters. Can the height be minus?
No.
Yeah. So comment on the validity of the prediction means, of course, the height cannot be negative. So the model is not valid for 15 meters. What is the basic understanding in this problem, Lakshmi? There are one concept is very basic here. Whenever the body is at rest, you should take the motion as 0.
Okay.
Still not released. Okay, that is the takeaway here. In this problem, the takeaway is that when the body is at rest, it is not at released from your hand. You are not at moving from your place. That means the body is at rest. Okay, and everything else is your equation. Equation is already given. You don't have to form the equation. Sometimes what happens, you have to form the equation. You have to do the x value y. You will learn it. Eventually, when you start, don't worry. Eventually, when you start, you will learn it. Okay, you just now started. You've kept the first step, so it feels like that. So you will learn that. Okay, but it's not tough. Only thing it is required is the practice. Once you're done with the class with me, you simply go through the problems again. If you don't solve, also go through the problems again. Okay, but whichever you feel little different problem or a little from out of the scale, then you try to solve it. Otherwise, you just see the problem, you will understand better.
Okay.
And it will register for you also. Here, remember, in mechanics, it's not like every problem is of the same kind. Understanding the logic and then solving it is very important.
Okay. True.
Understanding the logic plays a very important role. See this? Now go with the second question. Let us see. The equation is already given. Okay, try this one now. I'll just take my pen tab. 1 second.